plan is to turn 1 3/4 of this into a hex nut with the dimensions of a 3/4 inch nut, which is 1.125 inches across the flats, if I remember right. The way I'm going to do that, since I don't have a 5C spin index, is use this 5C collet device that I found among my stuff. I will get a 5C collet. I'll stick the 1.125 inch diameter piece into this 1 1/8 inch 5C collet. Stick that baby in there. Basically tighten it up and then stick it in my Kurt and then mill a flat, turn it, mill a flat, turn it, mill a flat, keep doing that till I'm finished. The question is, how much do I take off in order to get the flat the right width? I don't know. So what I'm going to do is carefully measure a 3/4 inch nut and then keep taking a cut across there until I determine the right depth by measuring the width of the cut. I think the right width is 1/2 inch. So that's the plan. Let's see if it works. The flats have to be 5/8 inch, and I don't know how deep to go to achieve a 5/8 inch flat. So what I'm going to do is noodle my way down there and measuring the flat when it looks like it gets close to 5/8 inch. I'm going to take the initial cut of 10/1000ths just to see how my setup appears, and I'll measure that and we'll go from there. I'm turning it at 110 SFM with this 4-flute TIN coated high-speed steel end. Things went fine, so I'll take some more and be back when I have something to report. My way down to about we're at 21.5 30 seconds, and I need to go to 20 30 seconds. So I'm going to take 5/1000ths off. You know, I'm going to take about 3/1000ths off instead. I really believe in this noodling operation. Let's noodle 3/1000ths off, measure it again. Getting a real nice cut. See both sides of the end mill in the cut, so that means my tram is looking good. All right. My noodling instincts were pretty good here. I think I'm just a hair short. If I could see better, I'd know for sure. No, I think I'm right on the money. So, looks good to me. I'll be back. Had a diameter of 1.1225. I found the right width here when I went down 98 thousandths. When I went down 98 thousandths. And I based all that upon the measurement that I made by hand from here to here as good as I could, and then duplicated it right there with some serious noodling. The last 6 or 7 noodles were at a thousandth of an inch. I know you can't see anything. I rather tell by me setting this knot on top of it, but it looks like it's right on the money. I will suppose I'll know for sure when I make the last cut. This is the final cut to depth on this second slot, or second surface. Of course, then I have to move the end mill over, move the table over twice in order to get it full width. But it looks good so far. Took some serious noodling to achieve this depth. Move over 1 end mill width, or almost 1 end mill width, and take 30 thousandths, 30 thousandths, 20 thousandths, and see, what's that put me at? 90, and then 8 thousandths, for a total of 0.098 thousandths depth of cut. I've completed the second cut. My surface is blended very well with my homemade DRO. I found this shoulder using the paper method plus a 1/2 thousandths, and it looks good, feels good. So I'll rotate it another step, another 60 degrees, and continue on. Stuck this dial indicator on the mill using kind of a Rube Goldberg combination of Mighty Mags. There never seems to be a great place to stick these Mighty Mags on my mill, and the holes in the Mighty Mags for me, always seem to be 90 degrees in the wrong direction. And be that as it may, I can now return to that shoulder with some ease. There we are. So I'm going to flip it and not flip it, but I'm going to rotate it the final 60 degrees and take the last cuts. I'm taking 30, 30, 20, 10, and 8 to reach my total depth of 98 thousandths. This is my poor man's work stop. Or maybe not. Maybe everybody does it that way. I don't know. Don't want any chips in there. So there we go. Take it 30 thousandths inch cut. Another 30. And I just arbitrarily decide on these depths. There's no magic about them. Carefully position 8. Slow speed so I can get a nice finish. my shoulder. I met my shoulder real nicely. And now I will take a cut here and a cut here. And the mill work on that nut will be complete. I will I'll get back to next steps in a minute. This is the final cut of 8/1000 on the final side. So there we go. I'm not real sure what size it is. Hold a minute, I can figure it out. It's this size. It fit perfect. Why did I ever doubt myself? It fits perfect. I really don't know what size it is. It's close to 3/4 inch or 7/8 inch wrench. Close, but not close enough. It's not an inch. So if I was shooting to make a wrench fit it, I failed. Unless I could get a 15/16 on there. Do I have a 15/16 up here? Let's see. Yeah, but I don't have. Oh, yeah. Look at there. It might be a 15/16. A little loose. Maybe it's a 31/64. All right, next step. Where's my pointer? What to do with it? Here's a different one. Oh, there it is. It was hidden. Next step. I need to, the nut is going to be this long. I'll part it off here and then stick it in the lathe and clean up this end of it and chamfer it and then thread it 3/8 24. What's the next move?